Imagine standing at the edge of the most destructive force in the universe, a black hole, a cosmic monster so powerful that not even light can escape its grasp. Now imagine falling in. What would you see? What would you feel? Would death be instant, or would you survive long enough to witness something no human has ever seen? Today, we're going on a journey that breaks every rule of physics you've ever learned. We're going to fall into a black hole together, step by step, from the moment we approach to the final moment before, well, you'll see. By the end of this video, you'll understand why black holes are the universe's ultimate mystery, and why falling into one would be the most mind-bending experience imaginable. Let's begin. Before we fall in, we need to understand what we're dealing with. A black hole is what happens when a massive star dies. When a star runs out of fuel, it can no longer fight against its own gravity. It collapses in on itself, compressing all its mass into an impossibly small point called a singularity. The gravity becomes so intense that it warps space and time itself. There's a boundary around this singularity called the event horizon. Cross that line and there's no coming back, ever. Even light, traveling at 300,000 kilometers per second, can't escape. Black holes come in different sizes. There are stellar black holes formed from collapsed stars, weighing about 5 to 100 times our sun's mass. Then there are supermassive black holes, lurking at the centers of galaxies, weighing millions or even billions of times more than our sun. The black hole at the center of our Milky Way galaxy, called Sagittarius A, weighs about 4 million times more than our sun. But don't worry, it's 26,000 light-years away. We're safe. For now. For our journey today, let's imagine falling into a supermassive black hole. Why? Because with a stellar black hole, you'd be ripped apart almost immediately. A supermassive black hole gives us more time to observe what happens, more time to experience the impossible. Ready? Let's start falling. You're in a spaceship, approaching the black hole from a safe distance. At first, it doesn't look like much, just a perfectly black sphere against the stars. But something's wrong with the stars around it. The stars behind the black hole appear distorted, bent around its edge in a perfect ring of light. This is gravitational lensing. The black hole's gravity is so strong it's literally bending the path of light from stars behind it. As you get closer, you notice something else. The black hole appears to be spinning, dragging space itself around it. This is called the ergosphere, a region where nothing can stand still. Space itself is being pulled around the black hole like water circling a drain. You check your instruments. Time to make a decision. Do you turn back, or do you cross the point of no return? You've come this far. You decide to continue. You shut off your engines and begin free falling towards the event horizon. There's no sound, no dramatic music, just you alone falling into the abyss. And then you notice something strange happening to your body. Your feet are closer to the black hole than your head. That means the gravitational pull on your feet is stronger, much stronger. At first, it's just uncomfortable, like someone's pulling on your legs. But as you get closer, the difference in gravity between your head and feet becomes extreme. This is called a tidal force. You begin to stretch, slowly at first, then faster. Your body elongates like taffy being pulled. Your bones creak, your muscles tear. This is spaghettification, and it's exactly as terrible as it sounds. But here's the thing. With a supermassive black hole, this happens relatively slowly. You'd actually cross the event horizon before being completely torn apart. With a smaller black hole, you'd be shredded long before reaching it. Let's say you're still intact as you approach the event horizon. You look back at your spaceship, which stayed behind. Something impossible is happening. Your friend is watching from the spaceship with a powerful telescope. To them, you appear to be slowing down. You're moving slower and slower as you approach the event horizon. Your movements become sluggish, like a video in slow motion. Eventually, from their perspective, you freeze. You appear to stop at the event horizon, never quite crossing it. Your image becomes dimmer and redder as the light from your body gets stretched by gravity, shifting toward red wavelengths. Eventually, you fade from view completely. But that's not what you experience. From your perspective, nothing strange happens at the event horizon. You don't slow down, you don't freeze, you cross it in a normal amount of time, maybe just a few seconds. This is Einstein's relativity in action. Time passes differently depending on gravity. Near the black hole, time slows down relative to someone far away. To your friend, you take forever to fall in. To you, it happens quickly. You've just crossed the event horizon. There's no flash of light, no warning sign, no sensation at all. You simply cross an invisible boundary in space. And now there's no escape. Every path, every direction you could possibly travel leads inward to the singularity. Even if you had a rocket capable of traveling at light speed, you couldn't escape. The geometry of space itself has been so warped that outward no longer exists. What do you see? Looking back behind you, back toward the universe you came from, you see something stunning. All the light from the outside universe is compressed into a bright, shrinking circle. You can see stars, galaxies, everything, all squeezed into this glowing disk that's getting smaller. Looking ahead towards the singularity, you see nothing. Perfect blackness. No light has ever escaped from that direction, so there's nothing to see. But something else is happening. The tidal forces are getting stronger, much stronger. Your body is now being stretched to the atomic level. Your cells are torn apart. Your molecules are separated. Your atoms themselves are being ripped into their component parts. You experience a level of pain that no human words can describe, but it only lasts a moment. Within seconds, you cease to exist as a coherent structure. But let's imagine, hypothetically, that you could somehow survive reaching the singularity. Some theories suggest that rotating black holes might contain a pathway to another region of spacetime, maybe even another universe. These are called wormholes, and they're purely theoretical, but they're mathematically possible in Einstein's equations. Could a black hole be a portal? Probably not one you'd survive traveling through, but it's a fascinating thought. Let's be realistic. If you fell into a black hole, you wouldn't experience most of what I just described. You'd be dead long before reaching the singularity. Spaghettification would kill you first. For a stellar mass black hole, this would happen well outside the event horizon. For a supermassive black hole, you might survive to cross the event horizon, but you'd die shortly after. Even if somehow the tidal forces didn't kill you, radiation would. As matter falls into a black hole, it heats up to millions of degrees, producing intense X-rays and gamma rays. This radiation would fry you instantly. And if you somehow survived that, the stretching of your atoms would eventually cause your molecular bonds to break. You'd be disassembled at the most fundamental level. But the fascinating thing is that from your perspective, the journey would feel quick. Time dilation means that while the outside universe ages billions of years, your final moments might last only seconds from your point of view. Black holes represent the ultimate mystery of our universe. They're places where our understanding of physics reaches its limit, where time and space become so warped that our equations break down and our intuitions fail us. We've mapped black holes across the universe. We've photographed the shadow of one. We've detected gravitational waves from black holes colliding, but we'll never truly know what happens inside. The event horizon keeps those secrets forever. Yet scientists continue studying them because black holes hold clues to the deepest questions in physics. How does gravity work at the quantum level? What is the true nature of space and time? Could there be other universes? The answers might lie beyond the event horizon, in a place we can never observe. If you found this journey fascinating, hit that subscribe button. We explore the biggest mysteries of space and the universe on this channel, from the death of stars to the birth of galaxies, from dark matter to the edge of the observable universe. What cosmic topic should we dive into next? Let me know in the comments. Would you want to explore what happens inside a neutron star, or maybe journey to the edge of the universe? Drop your suggestions below. And if you made it this far, you're clearly curious about the cosmos. That curiosity is what drives humanity forward to understand our place in this vast, mysterious universe. Thanks for watching, and remember, the universe is stranger than we can imagine. Sometimes the most mind-bending truths are hidden in the darkest places. See you in the next video.